Hello viewers, I am Kausalya. Today we are going to solve exercise 8.4 under the topic trigonometric ratios. Problem number 1. Express the trigonometric ratios sin A, secant A and tan A in terms of cot A. That is, you have to express sin A in terms of cot A, similarly secant A in terms of cot A and finally tan A in terms of cot A. Right. So first we are considering sin A. So here sin A it is nothing but 1 by cosecant A. Right. So this cosecant A can be written as square root of cosecant square A. Right. Because this square and this square root cancels each other and finally we will be having our cosecant A. Right. So cosecant A is written as square root of cosecant square A. So what is the formula for cosecant square A? It is nothing but 1 plus cot square A. Right. So finally, sin A is expressed in terms of cot. Right. This is the thing we actually want at the end. There should be no other terms apart from this cot. Right. So here we are having only 1 divided by root of 1 plus cot square A. Right. And the next thing is expressing secant A in terms of cot A. Right. So secant A can be again expressed as square root of secant square A. Right. And secant square A is nothing but 1 plus tan square A. And again the tan square A can be written as 1 by cot square A. And once you take LCM, here you see it is cot square A plus 1 divided by cot square. Right. So now we are taking the square root for both the numerator and denominator. Right. So here you see in the numerator we are having two terms with the addition sign, right? That too in addition. Therefore, so this cot square A plus 1, this will remain as such, right? Therefore, square root of 1 plus cot square A. And here this cot square A, once it is taken square root, then it is represented as cot A, right? So finally, secant A is represented in terms of cot. Okay, you see here in the final output we are having cot term, then apart from that there is some 1. That's it. Right, no other secant sign, something like that. And finally expressing tan A in terms of cot A. So it is very easy, right? Because tan A is nothing but 1 by cot A. Right. So first problem gets over here. We will move on to the next one. So this is our problem number 2, right? So write all the trigonometric ratios of angle A in terms of secant A, right? So here the thing is we should express all other trigonometric ratios. So how many trigonometric ratios in total? Totally we are having 6, right? So in this 6 that we should express everything in secant A. That is, you have to express 5 other trigonometric ratios in terms of secant A. Right, we should leave secant A and the remaining terms we should express in terms of secant A. So first one is sin A, right. So here we are multiplying and dividing this sin A by cos A, right, because we want to have our secant A, right. So we are multiplying and dividing by cos. So again when you rearrange sin A by cos A, it is represented as tan A, right, and here this cos A is represented as 1 by secant A, right. So again tan A is written as square root of tan square A divided by secant A. So what is the formula for tan square A? It is nothing but secant square A minus 1 divided by secant A, right. So finally sin A is represented in the form of secant. Okay, this is what we need, right? We should express all other trigonometric ratios, that is sin, cos, tan, cosecant and cot in terms of secant. So first we have shown that sin A can be represented in the form of secant A here, right. Now the next thing is cos A. So cos A, it is nothing but 1 by secant A. So cos is represented in the form of secant, right. And the next one is tan. So tan A is expressed as square root of tan square A, right. And again the tan square A is nothing but secant square A minus 1, right. The next one is cosecant A. So cosecant A is nothing but this is reciprocal of sin A. So we already know what is the value of sin A, right. So this is your sin A. So just take the reciprocal. So here it is secant A by root of secant square A minus 1. And the next one is cot A. So here cot A is nothing but it is a reciprocal of tan A, right? We had framed an expression for tan A, so just take the reciprocal, right? So finally we have expressed all the trigonometric ratios in terms of secant, right? So our third problem here, evaluate, okay, first option. Sin square 63 plus sin square 27 divided by cos square 17 plus cos square 73, right? So here in this case, you see, I am writing this 63 degree as 90 minus 27, right? And similarly in the denominator, here we are having cos square 73, right? This 73 is written as 90 minus 17, right? So what is the need why we are converting like this is, you see, sin square 90 minus theta, that is generally sin 90 minus theta is nothing but this is our cos theta, right? So sin square 90 minus theta is cos square theta. What is the value of theta here? It is 27. Therefore cos square 27, right? So plus this sin square 27 as such, right? Because when you have values of angles like this, we have to convert, okay? We have to convert one form, that is sine to cos, right? So only we can easily get the answer, or else how to find a value of sine of 63 and sine of 27? We don't have exact values in the trigonometric table, right? So we are making a idea to convert, that is, you see, when you look at this expression, it is cos square theta plus sin square theta. Similarly here also we are modifying, you see, cos square 90 minus theta is nothing but sin square theta. What is the value of theta here? It is 17, right? Therefore here it is sin square 17. So cos square theta plus sin square theta is 1. Similarly cos square 17 plus sin square 17 is also 1. So 1 by 1 is equal to 1 here, right? You can solve by this way, or you can take these two terms, okay? You can keep these two terms as such, and you can modify this term and this term. Okay, wait, let me show you that also. So you see here, this sin square 63 and cos square 73 are kept as such, and sin square 27 is written as sin square 90 minus 63, and similarly cos square 17 is written as cos square 90 minus 73, right? So here sin square 90 minus theta is cos square theta. What is the value of theta? It is 63. So cos square 63, and here cos square 90 minus theta is sin square theta, and again it is 73, right? So sin square theta plus cos square theta is 1, and again here sin square theta plus cos square theta is again 1. So 1 by 1 gives you 1 here. Okay, anyway you can solve. Now the second part of your third problem, that is sin 25 into cos 65 plus cos 25 into sin 65. Here also the same thing, you see, we are keeping the sin term here, and I am writing this cos term as, that is cos 65 is written as cos 90 minus 25, right? So cos 90 minus theta is nothing but sin theta. Here the value of theta is 25, and the sin 25 remain as such, right? So sin 25 into sin 25 becomes sin square 25, right? Now we will look at this part. So cos 25 is written as such, and sin 65 can be written as sin 90 minus 25. Okay, 90 minus 25 gives you 65 here. And again sin 90 minus theta is cos theta. Therefore here it is cos 25, and cos 25 into cos 25 gives you cos square 25, right? So sin square theta plus cos square theta gives you the answer 1, right? Now in other words the same thing, right? You can keep this cos as such, and you can write expression for sin. And here also you can keep your sin, and you can write an expression for cos. Okay, in both ways it is correct. So here you see sin 25 is written as sin 90 minus 65. So sin 90 minus theta is nothing but this is our cos theta, right? So here the theta value is 65, so cos 65. And again cos 65 into cos 65 becomes cos square 65. Similarly, so cos 25, right? So here in this case we are keeping this sin 65 as such here, right? So here it is cos 25 is written as 90 minus 65. So cos 90 minus theta is sin theta. So here again theta is 65 and these two when get multiplied it becomes sin square 65. So cos square theta plus sin square theta becomes 1 here. Right, in both ways you can solve the problem. Now our fourth problem. Right, so here the thing is choose the correct option, justify your choice. So the first one is, you see, 9 secant square a minus 9 tan square a. So in both these terms we are having 9, right? So I am taking this 9 commonly outside. So when you take 9, what about the remaining terms? They are secant square a minus tan square a. So secant square theta minus tan square theta is equal to 1. This is our identity. So this term is modified by, is replaced by 1. So 9 into 1 gives you 9, right? And your second thing is 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. So the first step is, you see, we are expressing tan and secant in their basic forms. That is, tan theta is nothing but sin theta by cos theta and secant theta is 1 by cos theta. And here similarly cot theta is represented as cos theta by sin theta and this cosecant theta is represented as 1 by sin theta. Right. So the next step is we are going to take LCM because you see these three terms are with a plus sign here. So once you take LCM, what happens? 1 into cos theta becomes cos theta. So plus sin theta plus 1. And here also 1 into sin theta is sin theta plus cos theta minus 1. The whole thing divided by sin theta. Right. So when you observe carefully, you see now we are going to multiply these two terms. Okay. So we are taking this part as A and this as B, and again here this as A and this as B. So here it is A plus B and here it is A minus B. Right. So A plus B into A minus B becomes A square minus B square. Right. So A square means cos theta plus sin theta whole square minus B square means 1 square. Right. Divided by here cos theta into sin theta. Right. So in any way you can write, right? Either you can write sin theta plus cos theta whole square or cos theta plus sin theta whole square. Okay, it will never make a difference because they are in addition, right? That is 2 plus 3 can be written as 3 plus 2. That's it. So now a plus b whole square, right? So we can expand this term in that formula. So what is the expression? It is a square, that is this is your a and this is your b. So a square sin square theta, b square cos square theta plus 2ab, 2 into sin theta into cos theta minus 1 divided by sin theta and cos theta. Right. So sin square theta plus cos square theta, it is nothing but it is 1 plus 2 sin theta cos theta minus 1 divided by sin theta and cos theta. Now this plus 1 and minus 1 get cancels and finally we are having 2 sin theta cos theta divided by sin theta cos theta. So these two terms cancel each other and similarly cos theta. So here finally our answer is 2. Right. Now we are moving to the third part. So our third question is secant theta plus tan A into 1 minus sin A. Right. So again secant A is written as 1 by cos A and this tan A is written as sin A by cos A and here 1 minus sin A. Right. So again when you closely observe, you see this is of the format a plus b and this is of the format a minus b. So a plus b into a minus b can be written as a square minus b square. So a square is 1 square minus sin a into sin a becomes sin square a. So 1 square minus sin square a, here this denominator cos a here. So what is the formula? What is the identity? You see cos square a plus sin square a is equal to 1. So when you move this sin square a to the right hand side, that becomes 1 minus sin square a, which is nothing but cos square a, right? So here 1 minus sin square a is replaced by cos square a, and again this cos a and cos a cancels each other and finally we are getting the answer as cos a, right? We are moving to the last part in our fourth problem, that is 1 plus tan square a divided by 1 plus cot square a. Right. So here simply I am writing this cot in the form of tan. So therefore here it is That is, the numerator we are keeping as such, and the denominator term 1 plus cot square a becomes 1 by tan square a. Right. So the next step is we are going to take LCM for the denominator part. So 1 into tan square a becomes tan square a plus 1 divided by tan square a. Now the next step is I am bringing this denominator to the numerator part. So this term will appear as a reciprocal. Right. So here write this term as such. So 1 plus tan square a multiplied by this becomes tan square a by 1 plus tan square a. So again these two terms cancel each other, and here the final answer is tan square a. Right. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.